Let's look at a simple tree in which we have two taxa and a branch between them. Taxon A evolving to taxon B, or vice versa. We have a model that says change is equal to the rate times the time. It's very difficult to say this is time or rate because they're multiplied together. We've also collected some data. Let's say there are 100 sites, and from those 100 sites we've observed 10 differences between taxon A and taxon B. What is the probability of observing 10 changes given a model and a branch length this long? If we have the number of changes here and time here, we're going to see that change goes up as time goes up, right? Something important there is that if time is 0, the probability of observing 10 changes at time 0 is 0, right? We've had no time with which to accumulate change. As time goes to infinity, we can have more and more change, right? Now let's look at this a different way. What if on this axis we had the probability of 10 changes, the probability of observing 10 changes? What's the probability of observing 10 changes at time 0? 0. The probability goes up with time. But then something interesting happens. It starts to go down, such that as time is much longer, the probability of observing 10 and only 10 changes goes down. So what we're looking at is the amount of time that should occur in order to maximize the probability of observing 10 and only 10 changes. Does that make sense? Just like at time 0, the probability of observing 10 changes is 0. At a very long time, the probability of observing 10 and only 10 changes is also very low. So this describes a maximum likelihood curve where we have a peak right here and we have a time that we'll be able to associate with a branch length, such that at a given period of time, the probability of observing 10 changes between A and B is maximum right here. So that's a maximum likelihood.